ArcGIS 105 Survey of Computer Information Systems course, you learned that computers and smartphones and tablets are electronic devices that are binary. They really only understand sequences of ones and zeros, or high and low current. The early computers, back in the 1940s, took up entire rooms, and data was inputted and instructions were inputted into those computers via switches. And those switches represented zeros and ones, and the output were lights. And those lights also represented zeros and ones, and so those running the computer had to know what those different sequences of lights meant in terms of output. And this was primarily doing mathematical calculations. The very first PC device that came out back in around 1978, I think it was the Altair. And it was a kit that you could build, and it also utilized switches for input and lights for output. It was shortly thereafter that Steve Wozniak and Steve Jobs came up with their Apple device, and the second rendition of that Apple actually used a keyboard. We'll talk about how binary comes into play in using a keyboard in a minute, but I want you to realize that in Visual Studio, when we click the little green triangle up in the button bar, the Start button, it takes our source files. That's the code we write, the screens we design, and other stuff that Visual Studio is doing for us in the background. It takes all that and compiles that into an executable binary file. It, in essence, is translating our English-like code into the zeros and ones that the computer will understand based on what we've asked the computer to do with our code. So let's talk about binary, decimal, and hexadecimal. So if you think back to your second grade math, we've learned the decimal system. And a number like 736, we learned, contains 6 ones, 3 tens, and 7 hundreds. Each of those digits has a place. The ones place, the tens place, the hundreds place. And we can think of that number as simply being 7 times 100 plus 3 times 10 plus 6 times 1. So 700 plus 30 plus 6, and we get 736. When I press a Shift A to create a capital A on the computer, the keyboard is sending a signal either through the cable or through wireless of high and low voltage sequence. In this case, that sequence is low, high, low, 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 high. And that represents a capital A. If I don't hold the Shift key down, I'm going to get a small a, and the sequence is slightly different. Here I'm getting a low, high, high, low, 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 high. If I do a Shift B or a capital B, it's a totally different sequence. So each key on our keyboard sends a different sequence to our computer. It really is voltages, but we can think of it in terms of zeros and ones for these different sequences. And so a capital A is a 0, 1, 0, 0, 0, 0, 0, 1. A lowercase a is a 0, 1, 1, 0, 0, 0, 0, 1. And an uppercase B is a 0, 1, 0, 0, 0, 0, 1, 0. Again, representing that voltage by zeros and ones, and we say the computer really understands zeros and ones. It really understands voltages. We learned, of course, that each 0 or 1 is referred to as a bit, and 8 zeros and ones together is referred to as a byte, spelled with a Y. Representing these characters as a byte value, 8 bits, is what we call an extended Ascii format. And it's kind of the point we kind of refer to it as Ascii as well. Ascii traditionally was 7 zeros or ones, way back when, and in about the 1960s, I think it became extended Ascii, and we added on more characters. You can Google Ascii and find tables of the different characters based on these sequences. Today we refer to this more or less as UTF-8, what we call Unicode. And there are various versions of Unicode. So the UTF-8 is a universal transformation format that is 8-bit, or 1 byte. there are 256 unique combinations of zeros and ones, and so we can have up to 256 different characters. Now, some characters in this UTF or ASCII format are not visible characters. There are things like carriage returns, or the tab key, or a beep sound or a bell. Microsoft Windows today, though, does not use UTF, it uses UTF-16. So in reality, when I press the Shift A or a capital A, the signal that is sent is not 8 zeros and ones, it is 16 zeros and ones. It's 2 bytes. But that added byte, in this case, is all zeros. But this gives me up to over 65,000 different values, and allows us in our fonts to include things like Chinese characters, Greek, Hebrew, different visual items, even emojis or icons. So that is the binary representation of each of these characters, but they also have a decimal representation. So a capital A is 65, a lowercase a is 97, and a capital B is 66. And we can actually convert between the binary and the decimal. Now remember, in the decimal, we talked about places being ones, tens, hundreds, thousands, and so forth. Well, in a binary system, our places reading from the right are the number of ones, twos, fours, eights, 16s, 32s, 64s, and 128s. And so in the case of a capital A, I have 1, 1, and I have 164, and 64 plus 1 is 65. That's how we can convert between the binary and the decimal. So in the lowercase a, we have 1 plus 32 plus 64, and that's 97. Now, an easy way to remember these places are we start with 1, thinking either a 0 or 1 here, and then it just doubles each place to the left. So 1 doubled is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and so forth. If I added 1 to the ones place, I now have a 2, and I'd get a 1, 0 here. And that's what we see in the capital B. So in the capital B, we have a 2 plus 64, and it's 66. Uppercase A through uppercase B are sequential in order. We're simply adding 1 to each letter. The lowercase letters, in this case, are the same as the uppercase, but with an added 32 value. The way you can figure out what the decimal value is of a letter is I just remember that A is 65. And so I know that, okay, B is 66, C is 67, D is 68. And if I wanted the lowercase value of any of those, I just add 32. So 32 plus 65 is 97. It's an easy way to remember these or work this out on paper if you ever need to, of what is the ASCII value of a particular letter. Now, these are based on fonts. And pretty much all fonts for the first at least 128 characters, if not the first 255 characters, are generally the same, other than some fonts that represent symbols such as wingdings or Zaf Chancery. One of the things you can do in Windows is bring up the character map. You'll find that in the Windows Utilities. And here you can see how each font is mapped in terms of different characters. So here's our capital A. I'm going to click on it. And what we're getting here is its value of 0041. Now what's 41? Well, 41 is a hexadecimal value. So each of these is represented by binary, decimal, and hexadecimal. I'm going to come into hexadecimal in a few minutes. But I want you to see that you can represent different characters here. And for example, if you wanted the copyright symbol, using this character map, you can select it and you can copy it. And let's say in Visual Studio, I want to have a label down here on the bottom that has some copyright information in it. And I can come to my label, and now I can do a Control V to paste, and I get the little copyright symbol, and I could put the year and my name. And there I'm now getting that copyright symbol as part of the text. So you can use the character map to copy and paste special characters and recognize that these characters extend way beyond, in this case, past the 255. So this is where we're getting that 65,000 different characters all different kind of characters as far as accents. So if you're working with a foreign language, you'll probably find the correct characters here that you need to use. You'll also find some Cyrillic characters, Hebrew characters, Greek characters, Arabic, and so forth. Now, the characters for each of these values will change based on what the font is that you're using. And of course, if we use something like Wingdings, those characters are not capital A's or lowercase a's or capital B's. They are little icons. You can also do a Google search for Ascii codes. And here's an Ascii code chart that shows you the letter. So here's our capital A, and we see it's a value of 65. Now I like this a lot because we can take that value. So for instance, I'm going to go back to the copyright symbol here is 169. So I know that when I want to use the copyright symbol, what I can do in Visual Studio or any other application, I can do it in Microsoft Office for this, is I can, rather than copying and pasting, I can hold down the Alt key and type 0169 on the numeric keypad, let go of the Alt key, and I get the copyright symbol. Or I can use those decimal values for each of the characters to my advantage and be able to type some special characters that maybe I use a lot. So we've seen the input of keyboards and the binary representation there. Let's look at the output of a monitor. A monitor is comprised of pixels. Each pixel is represented by 3 different colors set to levels ranging from 0 to 255. And those colors are red, green, and blue. So a red value can have a value between 0 and 255. The green has also a value between 0 and 255, and so does the blue. And that gives us actually 16.7 million different colors, and this is what we call a 24-bit color system. Each one of those values, red, green, and blue, are represented by a byte, or 8 bits. And so we have 3 times 8 bits is 24 bits. And so if we look at this value of zeros and ones for this brown color that's part of the sunset of this image, you'll see the first 8 represent the red, the second 8 represent the green, and the next 8 represent the blue. And we can convert those to decimal. We've already kind of looked at how to do that. And so this would be a color of 183 red, 112 green, and 67 blue, what we call an RGB value. And in Visual Studio, you can set any object to any color in that 16.7 million color palette if you know the red, green, and blue values. Now oftentimes we refer to colors though by their hexadecimal value. So whereas binary is a base 2 and decimal is a base 10, hexadecimal is a base 16 numbering system. And in a hexadecimal, each byte is represented by 2 digits. So here we have the B7, which is the red, the 70, which is the green, and the 43, which is the blue. Now if we were to think about a room where we have some overhead lights, and the ambient light in the room is determined by 3 sliders on the wall, 3 slider switches. And each switch has a value between 0 and 255, and any integer value in between that. If I go to the wall and move those switches to be all the way up to the high level, so we're going to flood the room with all the red light we can, all the green light, and all the blue light, and it's going to intermingle, and what we get is a color of white. You can think about the color prisms. Okay, so a 255 value for all of those gives us a color white, and every bit would be 1. Now the opposite side of that, if I took those sliders all the way down to the bottom, now the lights are basically turned off and our room is dark. So there is no light, there is no color, and so black is all zeros. RGB value would be 0 red, 0 green, 0 blue. And you see the hexadecimal values. By the way, hexadecimal values oftentimes are represented with a hashtag in front of them, or a 0x. So when you see that, that means it's a hexadecimal value. Now let's go back and look at that hexadecimal value for our brown color. It was B77043. So the B7 is the red. This is a base 16 system. The 7 represents the number of ones. The B represents the number of 16s. It's a base 16 system. We're going to have values between 0 and 15. Well, how do we represent 10, 11, 12, 13, and 14? And what we do is we use the letters A, B, C, D, E, and F. So a B then is 11. So I can show you the math over here of how we can convert from a hexadecimal to a decimal value. We take the 16's digit, which is B, that's a value of 11, times 16 is 176. I'm going to add to that the 7 value times 1, which is 7. Add those two together and we get 183. Same with the green. 7 times 16 is 112. 0 times 1 is 0, it's 112. And then for the blue, we have 4 times 16, which is 64. We're going to add 3 to that, and we get 67. So you can see on an FF, which would be the highest value we could have in any one of these colors, 15 16s is 240, and 15 1s is 15, gives us a 255. So that's how we can convert between hexadecimal and decimal. If you wanted to go the other way, from decimal to hexadecimal, you can take your decimal number, divide it by 16. That's going to give you the value that goes into the 16's digit. So if it came out that it was maybe a 12, you would have a C here, and then the remainder would be whatever's left over that digit. So if you had an E or 14 left over, it would be an E, it'd be CE. So we can always convert between binary, decimal, and hexadecimal. Now, why is this important? When you're working for a client, a lot of times they have brand guidelines. Their brand is very important to them, and the branding guidelines often include specific colors. So for South Mountain, if you look at the Maricopa Community College website, there's a branding guide there, and you can see the colors that are used for each of the colleges. For South Mountain, our RGB value is 207, 127, and 0, or here is the hex value, which is equivalent, CF 7F00. The CMYK here is used for printing and doesn't come into play with creating software for Visual Studio because we're always looking at stuff on the monitor. But this would come into play in doing brochures or magazines or ads, printed ads that would include stuff for South Mountain. And you'd work with this value possibly in a program like Photoshop or Adobe Illustrator or InDesign. Here is the branding guideline for Arizona State University. And we've talked about their colors are maroon and gold. You need to use the specific color of maroon and the specific color of gold if you're going to do any work for them. They have some accent colors here as well. One thing you'll notice, this branding guideline talks about typography. You're going to find that in every branding guideline. So not only are colors important to the brand, so are the fonts that companies use. So when you're working for a client, ask them about their brand, their branding guides or their brand guide, and we're going to discuss colors and typography, and also the use of their logos. Here's another one. This is Honeywell. Their colors are primarily Honeywell red, black, and white. And you have the RGB values here. This web hashtag is the hexadecimal value. And here is Intel. So Intel basically has two colors. They have their logo blue and white. This is Pearson, who is the publisher of our Dytel and Dytel Brothers textbook. And you can see they have their brand colors, they also have primary colors, and they have supporting colors or accent colors. Again, they give you the CMYK for print, but they also give you the RGB as well as the hexadecimal. So the brown color that we came up with off of that monitor, if we wanted to use that color, RGB values are 183, 112, and 67. In Visual Studio, you can use hexadecimal values, but if you wanted to do things as far as properties on the visual side of things, the colors are set via RGB. You can also use the RGB values in the code as well. There is a fourth channel, which is an A channel, which is the alpha, and so you can make things transparent or semi-transparent by setting that alpha property. So here now is Visual Studio, and let's say I want to set the background color of this form. I'm going to click on the form. So I'm going to the back color because I think I'm going to run out of some room here at the bottom. I'm going to pull my properties palette off and let it float. So I'm going to go to the back color. I'm going to click on the custom tab, and there's the basic colors here that are part of this coloring system, but then I can also create my own custom colors. To do that, I can right click on that swatch, and here I can put in the red, green, blue values. So we had 183, we had 112, and we had 67. And there is that brown shade. I can say add color, and I've colored the background. It's also now part of my swatch for this project, and I can use it elsewhere. So now you know all about binary, decimal, and hexadecimal values and converting between them.